All right. So hopefully you're at least a little bit familiar with the plight of the insect. But according to that, let me just myself, I'm the director of the Sterling Nature Center. Sterling Nature Center is about 1,400 acres. We're on the shore of Lake Ontario in Cuyahoga County. Trail system is open every day of the year, sunrise to sunset, so you can come out and go for a hike. We're in the midst of a improvement project. We're building a new interpretive center and doing some other improvements to the grounds and the trail system. So we're kind of in the middle of that, and the building will start going up next spring as soon as the weather breaks. So hopefully by next fall, we'll be in the new building and be able to do a lot more diversity of programs and things. So if you haven't visited us, please do. Part of the building project is planting native trees to supplement what has been taken down during the construction project and to rebuild the habitat around the building. So it fits into this presentation with what we're doing and using the native plants and that. This is a complicated topic, so if you have questions, please let me know. If I'm running too long, please let me know that as well, because there's a lot of material and it's tricky sometimes to go through. And I thought it would be easy just answering a few questions like I put up in the description, but then that gets all muddled together and things change. Not advanced. There we go. So the original study that kind of started this and got into the headlines was this study. It was done in Germany. This was the one that was published was October 18th of 2017. And then by 2018, there were a lot of headlines about the insect apocalypse and all that. So the Kerflid study, if I'm pronouncing that properly, what they looked at, or what the premise was trying to look at insects a different way. Most things were usually just based on a single species or a single taxonomic group, so either like the monarch butterfly or butterflies in general. They wanted to take a different approach to see what was going on with insects. So and to see how about the loss of diversity and the changes that were taking place in the environment. There we go. So what their procedure was, and they had been doing this, and they had the data for over 27 years of using traps to catch flying insects. And they would, one of the things they would do with those was weigh the insects to figure out what the biomass was of that. So they were doing this, and it was all in nature preserves in Germany. So 63 nature protected areas, 96 unique location year combinations. So fairly big sample size. And what they found was that things were declining and quite rapidly. So a seasonal decline of 76%, and that was kind of what made the headlines, a 75% decline in insects. The midsummer decline is even a little bit more scarier, 82% decline in the biomass of insects. And yet, one thing people tended to forget during these, when they're looking at the study, is it was only looking at the flying insects and the biomass of those insects. So that down the road, that becomes important because that was some of the criticism people put up against this study. And there's others that we'll get into as well and try to work through those. So some of the interesting things too with the study was the decline couldn't be explained by changes in weather or climate, land use, habitat characteristics, or habitat loss. And those habitat loss especially is what you always think of when you think of something declining. But that wasn't a factor in this study. And one of their big conclusions that I took from reading the paper was that the data, and this is a quote from the paper, the data themselves are strong. Understanding it and knowing what to do about it is difficult. So the data is there. There's a big decline in the biomass. But what does that mean? And what is causing it? People focused on the headlines a lot and not on the substance of it. This is a picture of one of the study sites. You can see the trap there. There's some wetlands around it, some forest areas, but also a lot of farmland around it as well. So even though they're taking the sample from a protected area, it's not a closed system, it's an open system. So things are coming in and out of that system. So you could surmise that something from the outside, especially being that close to the edge, is affecting the study of, or the life in that reserve. So the biomass, again, the loss of insect biomass must be taken into account when evaluating declines in the abundance of species dependent on insects and ecosystems functioning in the European landscape. So again, that's another quote from the study, and I highlighted this time the European landscape, because can you take this study and put it through the whole world is kind of, no, you really can't. You have to look at what the study was looking at. And that's kind of another factor that people missed and complain about the study, even though the study was telling you this is what we're doing. People just got a little bit upset over the more the headlines and what the press was doing with it than what the study was. So that's one thing to keep in mind, and we'll look at some of those things as we go through this. So why is looking at the biomass and the flying insects important? And part of what they were saying is, you know, what's going to happen with the food chain, and if the insects are at the base of the food chain, what's all the other components of the food chain? How are they relying on things? 60% of birds rely on insects as food, and 80% of wild plants depend on insects for pollination. So anybody know what flower that is? This is kind of my side question. Anybody know? Well, hepatica, sharp-lobed hepatica. So kind of an easily recognizable spring wildflower in the woodlands in our area. But then I thought, well, what about the beetle that's on there? Who knows what the beetle is? I think I looked it up at one point, and I don't remember what it was, but really, so the hepatica beetle would be probably a good name for it. But that beetle is pollinating the hepatica flower. We know the hepatica flower. We go looking for the hepatica flower every spring, but do we go looking for the pollinators of the hepatica flower every spring? No, it's different. Sharp-lobed hepatica is a common name. I mean, there's a couple of other varieties of hepatica. The hepatica is because of the shape of the leaves resembles what your liver looks like, the hep and all that part of it. So
Turn off this panel because let's see if I can get rid of it. There's the house. There he is.
yeah, let's see. It'll probably be in the way no matter where we put it at some point, but down there. There you go. So this kind of goes into the whole my side question of, you know, we know the flower, but do we know the beetle and everything else? Kind of goes into the whole problem with insects and with knowing what is declining and what is increasing and all that. If we've never studied that beetle and what it pollinates and how many of them are, how do we know they're declining and how do we know they're stable? So that was kind of their study. They weren't looking at individual insects. They were looking at the insect community to see if they could figure out what was going on with the insect community. And using the biomass, that was the data they had, so that's what they used. You could probably design a new study from scratch, which would be better, but then you got to wait 27 years to get your results. So trying to look back at data that's already been collected is what a lot of people did in this instance. The flying insects, what they do for us, pollinate flowers, provide food for a lot of animals. They're predators on a lot of things that may cause us trouble. They're also decomposers. And we tend to forget about the decomposers, but if we didn't have those things decomposing, everything out there that dies would still be there if nothing was decomposing. So we kind of forget about those, but they're very important in recycling the nutrients, getting them back into the ecosystem for things to benefit from. So my side question here, which is covered up again, yeah, that is going to be a problem, but I'll try to. So, and these side questions just kind of popped up the last time I was reviewing my program, which was this morning, and so I don't have too many of them because then I realized my program is going to get way too long. But anybody know what a springtail is? First of all, they're snow fleas are one component, one species of them that you see in the wintertime in January, February. You see them on the snow a lot. They're a small primitive insect that's a decomposer, mostly, but most people don't know they have them in their yard or in their neighborhood, let alone ever seeing one, because they're really, 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 really small. I should have put a picture in one, but at the Nature Center, there's probably millions or billions of them living at the Sterling Nature Center. They're all over, but you just don't see them. So how are their populations doing? We don't know, because I don't think anybody's studied their populations to see how they are. And they're one of the few insects that is found on every continent. There even are some on Antarctica. So they're worldwide, but how many studies have there been of them? And then if you like birds and other animals, then you need the insects, because that's what they rely on. And a couple of quick, neat little statistics. So 96% of North American land birds feed their young insects, even though they may be seed eaters the rest of the year. That protein coming from the insects to help those birds grow really quickly is very important. So Doug Talamay estimated 6,000 to 9,000 caterpillars to rear one clutch of Carolina chickadees. We have the black-capped chickadee in our area, so probably similar numbers for that. And you think of all the warblers that come through and everything else that's nesting in here in our area. That's a lot of insects they're consuming and they're eating and they're taking care of. So, and then the native and non-native plants. If you have less than 70% native in your yard or in your habitat, then it really starts to decrease the survivability of some of the wild animals that are feeding on those insects, that are feeding on all the native plants in your yard. So everything gets kind of connected together and just is something that we don't always think about. So if you don't care about the intrinsic values or the ecological values of the insects, then there is also an economic value to you. So pollination value, these are, I couldn't find anything really updated. I got these from a presentation that was done at the Virginia Museum on April 20th. It's, if you go to YouTube or you go to the museum spot, you should be able to find that presentation and you can watch it. It was a very good one of the ones that I watched in preparation for this. But his sources go back to 2006 for these numbers. So these numbers would be bigger. The value dollar-wise would have increased with inflation and everything else that's changed over the years. But these were the best data I could find. So pollination, the pest control, dung, which we don't think of too much in our area, but and also then the wildlife nutrition value of them. Somewhere around $57 billion worth of services the insects are providing. So they are very valuable to us in economic terms as well as intrinsic and ecological terms. So the question then becomes, is there an insect apocalypse, and has the science borne out the media blitz or hyperbole or whatever? Who says yes? Anybody say no? Don't know?
I have to clean my towel.
And that is one of the anecdotal things, is the windshield effect or the windshield phenomenon is one of the things that is talked about. So I tried to break it down a little bit and trying to figure out what we've done since then. So supporting the yes part of it is this, there are studies that are showing decline of insects. So that should be something we're concerned about. But it also should be that we need more data. So we need to be collecting more data. And again, there are a lot of studies, and I'll show some in a bit, that are showing the decline. The argument against the headlines, mainly, not necessarily the science, but against the headlines, would be like the German study was for Germany, and you could probably expand that to Europe, but expanding that to North America or Asia is really difficult because those are different communities. So going to a local study and saying it's a global result is difficult. So the decline globally is hard to look at. Then the lack of baseline data. So like I was talking about with the springtails, if you don't know how many springtails are in your yard today, how many were in your yard yesterday, how many were in your yard 100 years ago or 20 years ago, you don't have that baseline data to compare it. You don't know whether something's increasing or decreasing or healthy or not healthy. We all got into the habit of taking our temperatures over the last couple of years to check our health and stuff. So we knew what our temperature was and whether it was increasing or not. If you didn't have that baseline data for your own health, you don't have it for the future if you're getting sick or not. So there's a lot of biases in some of the studies that I'll talk about some of those. Some are more important than others. Again, extrapolating from one species or one taxonomic group to the whole world gets little science funky and not as reliable. And then there are some insects that are increasing. So what about those? And why are they increasing and why aren't others increasing? So I go back to that first quote I think I put up. The data themselves are strong. So the data of the decline is there. And then now our interpretation of the data, our understanding of the data, why that decline is taking place, those are all the things that kind of get muddled and confusing. But there is the decline. It's just why and what is occurring is the hard part. Move this down again. So populations of European butterflies down 50% since 1990. Honeybee populations in the US down. British moths down. And then the graph is showing hoverflies and bees. So hoverflies is the top line, bees is the bottom line. That trend is declining, so you don't want to see that trend. Seeing the bumpy line is fine, but that bumpy line should be more straight across and that declining slope. So we're losing those, or in this study in the UK, those species are declining. So those declines are there, and now understanding again why it's happening is the hard part. So And the title of this one I kind of like. So evidence is circumstantial, but it's also very substantial evidence. So a lot of decline. And so the threatened species are in the red, and the declining species are in the gold. So terrestrial and aquatic. For this study, aquatic was affected a little bit more than the terrestrial. The beetles, butterflies, and moths were affected a lot. Caddisflies, something that most people probably don't even know what a caddisfly is, have a really sharp decline. And they are have a nymph stage that's aquatic, so that may be part of their issue. The same thing with stoneflies, and you got grasshoppers and crickets. We all know and hear grasshoppers and crickets all the time, but how are their populations doing? Has anybody ever studied them? We tend to look at butterflies and moths, more butterflies and bumblebees and dragonflies, some of the more charismatic or the megafauna of the insect world, not necessarily looking at the other parts of it. The globe graph there is showing where these studies came from, and I'll look at a similar graph in a little bit that we'll talk about some of the biases of this type of study. So are we biased towards insects? I would think this group is probably biased towards the environment. My profession, I am kind of biased towards the environment. If you're an entomologist, you're going to be biased to want to favor the insects there. So then there's also confirmation bias, search bias, location bias, publication bias, and trying to figure out a last one for this that I kind of came up with, tunnel vision bias. But confirmation bias, if you think there's an insect decline, you're going to go look for evidence of insect decline. That's kind of what that one is. That's kind of the simplest one to look at. Search bias was a little bit difficult, but a little bit more difficult to understand or to look at. But I realized I did that when you first asked me to do this program. You asked me to do a program on insect decline. So what did I search for? I searched for insect decline. So that's what you do. So these are from the same source, the searches. One I searched for insect population trends. One I searched for insect decline. It's a lot easier to do insect decline than to do something else with insects. Insect increase doesn't come up with anything really. So how do you judge the whole health of the environment or of the thing if you're looking at studies? So in this one, I just did insect decline, and then I put insect decline debunked. So I got some different ones, even though in the debunked one, it does come up with some things about the insects being in decline. But something as simple as that, if you're researching somebody else's, and so a lot of the research that was done after 2017, the immediate time after that, because of the headlines and people wanting to look at it, a lot of literature people were doing that. We're searching for insect declines. So are you biasing your own your results that way by not doing a more general search? So that's one issue to be careful of. And then location bias. So this, I think this is the same study that we looked at in the previous one showing the globe. You can see where all these studies come from. So most of these studies are coming from North America and Europe. Very few from Africa. Very few, I don't think any from India. A few from Australia. Not too many from Russia. Not even too many from Canada. And even South America has very few studies as well. So trying to generalize the whole world when your studies are only coming from part of the world, becomes an issue that people look at. So you have to be careful of where the data is coming from and how you're interpreting the data again. And then publication bias. So the Kerford study tried to publish in Nature and Science, but they were rejected because they didn't think it would be of a sufficient interest. The article would be of a sufficient interest. They finally got it published in PLOS One, and then there was a lot of public interest. It just kind of blew up the next year. New York Times, every major publication was doing a story on that and what it meant. But that, again, with the publication bias, and then this one was kind of a little bit more striking. It's a long quote, I'm gonna read it to you. Publication bias is not about dishonesty or false results. It refers to the idea that more dramatic results are more publishable. Reviewers and journals are more likely to be interested in species that are disappearing than in species that show no change over time. The result is that over time, declining species can become overrepresented in literature. Then when scholars go looking for papers on animal population declines, and animal populations declines are predominantly what they find. And then this little tweet accompanied the article that quote comes from, where the journal wanted them to come up with something a little bit more sensationalized instead of just publishing what was in there. So that can be an issue and something to think of as we're going through in anything like this. So then tunnel vision bias is kind of a term that I think I settled on for this. So if you change your perspective, you're going to change how you're viewing things, is kind of what it is. If you're only looking for insect decline, you're only going to find insect decline. You're not looking at a wider problem with that. So some of the studies for North America are showing insects increasing. So why? So are they increasing because we lost a major predator of insects in the Northeast? And these data, these numbers for bats lost are 10 years old. I couldn't find anything updated. So about 10 years ago, they estimated that we lost about 7 million bats in the Northeast due to white nose syndrome. So if you extrapolate of how many insects a bat could eat every month, you're talking about trillions of insects that the bats aren't eating. So is that why insects are increasing in our area as opposed to not? Are we just looking at the insects, or are we just looking at the bats? Are we not looking at a bigger picture of the environment and what is going on in it? So those are some of the issues that have arose over the years since the study. So what have we learned? And for whatever reason, this quote from Donald Rumsfeld popped into my head when I started thinking this. We know what we know what we don't know, but we don't know what we don't know. And it's if you think about it, it does fit a lot of what is going on. We know certain things, but we don't know other things because we don't have the data to go back 50 years and look at them. And then there are a lot of things we never thought of to ask the question, so we don't know the answers to them. And the one thing species that popped up too with this was the 9-spotted ladybug here. So, and again, another long quote, sorry for it, but in 1989, New York designated the 9-spotted lady beetle as the state insect. It was then believed to be one of the most common and important lady beetles in agriculture areas in New York and the Northeast. Today, it seems to be extirpated, made locally extinct within the state, and it occupies only a tiny fraction of its former range across the United States and southern Canada. Recent surveys have found none in the Northeast and only a few in the Midwest and West. Although the spotted's decline was recent, little is known about when it vanished. Non-native lady beetles may have brought disease, eaten prey used by the 9-spot, or even eaten the 9-spot itself. The exact cause and the demise of the 9-spotted lady beetle remains an unsolved mystery. So a lot of things came to me from this. Is we're talking about a study that was released in 2017, and everything that it brought up. This was well before that study. There were big declines. Nobody paid attention to why this lady beetle was declining or what was causing it. So these declines aren't recent. They're not just from this study. These declines have been going on for years for certain species or certain taxa, and we just not paying attention to them as much as maybe we should be. So little ray of hope. There were some lady 9-spots found in Long Island in 2011. I did find a reference to a professor in Cornell that collected some of those and was trying to rear them in captivity to re-release them. I couldn't find any updates on that. So I'm not sure how successful he was or not. But so there are hope, and one of the good things with insects is they reproduce in large numbers. So if you can save a small part of the population and get them to breed again, you can hopefully get them back into the ecosystem. So their reproduction is a little bit favorable to them being saved if we can figure out why they're being lost and what we can do about them. Then that brought up the question to, have we actually learned anything? And will we learn from what we're doing now? And it also goes to, we're thinking of our life experience as being normal, but is that actually normal? Is my daughter's life experience, she's going to have think of things differently than I am or see things. I never saw American chestnut or streets lined with elm trees. She's not going to see beech forests or right now ash, emerald ash borer. So our ash is going to be gone. So the next generations are seeing things differently than the previous generations, but everybody thinks what they saw was normal. So it kind of creates this downward slope if things are decreasing. But kind of a down thing. And then, are we repeating the same mistakes? We know DDT was bad and what it did. Are we doing that same type of thing with some of the newer insecticides? So once thought to be harmless to wildlife higher up the food chain, scientists are increasingly reporting toxic effects of the neonicotinoid pesticides. And I'll talk a little bit about them. I think I talked more about them the last time, but I will update on some of that. One of my favorite slides, so it's kind of depressing, is we think of the mass extinction of the dinosaurs and what happened to all the dinosaurs, but what about all the little things that were living with the dinosaurs? So we tend, again, to focus on the megafauna. So insect world, that would be, again, the bumblebees, the butterflies, the dragonflies, those big things that we can see and watch and enjoy. But again, all the little things like the springtails, and even some of the smaller microscopic insects or close to microscopic insects that are out there. How are they doing? What are they doing? Even wild bees compared to honeybees. We tend to focus more on the honeybees than we do the wild bees, but that has changed over the last decade or so. But there's a lot of things that we just aren't paying attention to, or just don't know if it's lost. Like I said, the passenger pigeon, how many of us mourn the loss of the passenger pigeon? We never saw it, it's not around. So there are things like that that were a big part of the ecosystem that are gone now, and it's just hard to realize what we're missing. So I kind of already answered half this question. If there is a decline, what is causing it? So the if part we can take out because there is a decline. It's just how we interpret that decline and what we think of it. Most of these I think are the same as I talked about at the first presentation. Habitat loss, again, is usually one that we think of for almost anything in decline, any endangered species. The habitat loss is always very important with that. Climate change is one that we're really starting to get a grasp on right now and what it's doing, because we're actually starting to see the effects of it. But it is again a lot more complicated than we realize as well. So the altered precipitation patterns, so we may get the same amount of rainfall every year, but it may all come at one time instead of being spread out over the year. Changes in temperatures, the phenology, so when insects are hatching, when flowers are blooming, that may change as the climate changes, and that affects other things that rely on those. So if you're a warbler that relies on a mayfly hatching this week in May, and now that mayfly is hatching earlier in the spring before you migrate through, you're losing that big food source. So that phenology is something we don't think about all the time, but is very important. And then the availability of native plants as part of climate change. If things are shifting their range, it'll help some things, it'll hurt some other things. One thing I added that seems to be popping up a lot more in the literature is intensification of farming. I didn't have that one on the list last time I did this, but that is a factor that is showing up a lot more. That does go with pesticide use and land use changes. Light pollution I didn't have on this list either, but that is affecting a lot of different types of insects, moths, as well as lightning bugs and other things. And then other changes we're doing to the planet. The planet is a closed system. Everything that we put into the atmosphere is staying there. It's not going anyplace. I had this discussion with a friend from high school that was trying to argue that Onondaga Lake was a closed system and the Earth was an open system. I'm like, no, you got that backwards. And I don't know if he ever understood that, because he was arguing one thing that was not necessarily the right way to approach things. But and that's anything we're doing is staying within our planet. So that'll get down to the pesticide use that goes to climate change, and everything else gets kind of in that closed system of the Earth. I debated whether about including this graphic because I'm not sure of everything in it, but it does kind of give you an idea of the complexity of things and the size of the problem related to different aspects of insect decline. So the intensive agriculture is almost at 25%. Pesticide use, which you could put in with the agriculture, though there's other reasons that you use the pesticides. And you get fertilizers and deforestation, altering of the wetlands, global warming, pollutants in general, wildfires. So even with climate change, it's increasing the intensity and the duration of the wildfire season. It's also changing. You could also go with climate change and precipitation and other things that are going in there. So it's a little tricky to figure out. I'm not sure how accurate some of these percentages are, but it at least gives us an idea of the scope of the problems or the issues that we need to look at a little bit more. So habitat loss. I was trying to find an update to this graphic of percentage of wetlands lost. This one goes from 1780 to 1980 within those 200 years. So some of those things have changed. Some of them we've added wetlands in some cases. In some cases, we're still destroying wetlands. I also tried to find something on forests, how those have changed over the years. New York State, we're actually regrowing forests because of a lot of small farms going out of business. So a lot of farmland is being regrown. Sterling Nature Center, all that was the whole thing was small farms at one point, and now we have very few open areas. Most of it is regrowth forest. So those things have changed quite a bit. But normally with habitat loss, we think of it being destroyed. They're cutting down the rainforest, but that's one type of habitat loss. Just mowing your lawn is a type of habitat loss because you're mowing it and you're keeping it as a short grass instead of into an old field or to a forest eventually or something else. Then just degrading of the habitat so that it's not suitable for some of those wildlife is another big issue. Fragmentation, we've broken things up into little fragments, which causes other issues for wildlife. They can't move from one place or another. The edge effect, so if you're a predator, if you're like a crow, you can penetrate into the edges of the forest instead of going into the middle of the forest. And then isolation, if like Central Park, you can consider being very isolated. Could be considered a nice wildlife area, but it's also very isolated in the middle of the city. Other things like wetlands, the vernal pools at the Sterling Nature Center, they're kind of isolated within the Nature Center because of the farmland around it and the development around it. But within the Nature Center, there are other wetlands that can help rescue. So if something bad were to happen to one vernal pool, there's enough other vernal pools hopefully around that would lend species to that could help it recover. If you're isolated and you have nobody to help rescue your population, then if your population gets hit by a hurricane or something else, then that changes too. A lot of these things come down to the choices we make. So everybody, I think, was happy that Micron was going to come in and bring all these jobs into Syracuse. But then one thing, I kind of brought this one article saying that the complex you're hoping to develop is 1,400 acres. So, well, the Sterling Nature Center is 1,400 acres. So, in the Sterling Nature Center at one point could have been a nuclear power plant or a coal burning power plant or a landfill even, were some of the proposed uses for it. So the choices we make of what to do is what happens to the environment. So the little sign that the press was using of where the development for Micron is going to go, showing some nice little goldenrod and some other plants in the field, nice insect habitat. But it's the choices we make. My ecology professor back, this would have probably been in the late 80s when I was in undergraduate school, probably the only thing that stuck with me that he said throughout the class, I'm sure other things did, but one of his things was, if people are hungry, they're not going to care about the environment. So if your economy is not good, if you don't have the jobs, nobody's going to care about saving the butterflies because you're hungry, you need food, you need to. So those choices we make and how we make those choices is kind of interesting. Energy, again, is another one. I didn't put any slides in here about it, but putting up solar farms is another can be very controversial, but also very beneficial of what land you're using to put the solar farms up. When I was looking for a source for seeds for my seed beet program, one of the seed mixes that came up on from one of the companies was a solar farm mix. So you can still put in a solar farm, but you still need that. You want that grass to be low enough and the plants around it to be low enough. You don't want trees growing up in front of it. So a lot of them just mow the area around the solar farm, but without planting things that are going to be low to stay still benefiting the environment with the solar power, but you're also putting in the pollinator benefit as well. So there are a lot of choices, and we can mitigate the damage we do. So I think a lot of you are doing that with your own landscape around your house, putting in more native plants, taking out things. I was cutting down European buckthorn at the Nature Center a couple of weeks ago. I still got a lot of Japanese barberry to dig up. All those things came in from different things. So we can make the choices and change what we're doing. The insecticides, the neonicotinoids or neonics, are one thing that I talked about, and I'm not sure how much I talked about at the original presentation or in a subsequent one I did, but they're one of the pesticides that is looked at. They're a relatively new pesticide. In the 1980s, I believe they were introduced, and we're still trying to figure out the harm they're doing to the environment. These were some of the articles that I cited in the previous presentation. So reduction in honeybees, reduction in bird numbers, and kind of a newer one with the being found in the Great Lakes, in the tributaries and in the Great Lakes. So I tried looking up and finding an updated study about this, and I couldn't find one. Not saying there isn't one out there, but it's still just maybe that the studies haven't finished that they're doing. But they're finding traces of neonicotinoids in the water. So which means if they're in the water, then they're going to be, are they affecting the insects that are living in the water? Are they affecting the fish that are eating the insects? Are they affecting the birds that are eating the fish? How all this is going and what is going on. So one of the things they started to do to help reduce the drift of the insecticides onto margins of around the fields was they started to treat the seeds with the insecticide. So the neonicotinoids, what makes them a great insecticide is the plant takes up the toxin. So the whole plant becomes toxic eventually. So if you're a bee collecting pollen, some of that pollen you're collecting is going to have a little bit of this insecticide in it. Hopefully for the bee that it's not enough to make the bee sick or kill the bee, but it's why it works so well. So one of the things they were trying to figure out was why there was a big increase in the neonicotinoids in the water in the spring when they're not spraying, and it was because it was on the seeds. There's different regulations for spraying as well as treating the seeds. So it gets very complicated of how everything's interacting with the environment and what the effect is on everything. I came across this from the Audubon Society of Rhode Island that Dr. Charles Clarkson is just starting a study trying to see the presence of neonics in birds in Rhode Island. So, which I thought was a good study. You better tell if they're being transferred up the food chain to the birds. But then the title was kind of, to me, was a little bit depressing because the case against neonicotinoid insecticides is growing. I said, all right, so this has been going on for a decade, 2 decades that people have been complaining about it. But we still haven't come up with a conclusion that it is dangerous or not dangerous. So something that we should be using or not be using. The European Union and the European Commission being part of that has done a little bit more than the United States. So in 2013, they banned the use of 3 of the neonicotinoids on flowering crops and on some of the grain crops as well. And then in 2018, they banned all outdoor use of those 3. And then in 2020, they didn't renew the approval of a 4th one. So it was kind of another ban of those insecticides. So it sounds good. They're being proactive, a little bit more proactive than the US and some of the rest of the world. But then if you read the title of where I got this from, which is down in the citing there, why are banned bee killer neonicotinoids still being used in Europe? Right, so if they've been banned, why are they still being used? Because I think it was Article 52 of their law says, well, if there's an emergency, you can use them still. So everybody's defining what an emergency is differently, and some countries are allowing them to use them just as much than others. So it's, that again gets into the political things of everything. But at least the European Commission has taken a little bit more proactive ban on some of these. You can look up to DDT, it was banned in the US, but it was still being manufactured and shipped out to other countries to use. I think it's very recently that it's not being produced in the US anymore, or not being shipped out anymore. I meant to look that up and I forgot to, because again, that was going down another rabbit hole of side questions here. And this was kind of scary of how much we're using. So worldwide application of pesticide active ingredients. So this is just the active ingredients by country. And it's the annual average from 1990 through 2017 in tons. So 407,000 tons of insecticide were used each year in the US. China is a quarter of all the insecticide in the world is being used in China. So some of those things are kind of crazy. I mean, Ukraine being a big farming and grain producer, they use quite a lot for being a small country. Brazil, another large farming country, using quite a bit. But it's and again, it goes back to the Earth being a closed system. Where are these going after they're used? Are they breaking down like they should be or not? So it gets kind of, it's kind of an eye opener of how much we actually use. One of the things that pops up too with this is, if you're a farmer, you're kind of regulated on how much you can use on your crops. If you're a homeowner, you're not. You can go to a store and buy gallons of it and spray every tree and every plant, and there's nothing against doing that. It's not healthy for the environment, and probably not for you, but it's stuff that homeowners can do that some of the countries can't. So getting more to threats and specific species. So habitat loss, pesticide use, logging, and the overwintering grounds for the monarch butterfly. And then climate change is going to be another issue for them. Climate change could be, if all the conditions are right, could be very detrimental to the monarchs if we get a really big hurricane that hits Mexico after the monarchs have arrived there. You could wipe out most of the population with one storm very easily if it's a big enough storm, have enough rains, and all that bad stuff that hurricanes bring in. So the loss of milkweed, which I probably have talked about with different programs, having the herbicide ready crops, so where you can spray your soybeans with an herbicide that'll kill everything else except your soybeans or your corn crop, that has eliminated a lot of milkweed around the edges of fields or in the fields themselves. I let the milkweed grow in my vegetable garden. I kind of plant around it, but the farm fields around me spray, and the only thing that really comes up in them are the black walnut trees. Seeing it pop up every year through the insecticides, but most everything else is dead except for the soybeans or the corn. So it does eliminate, if you think of the large farming practices compared to the small farming practices, a lot of things are eliminated with some of those technology changes. Bumblebees, again, these are kind of the charismatic members of our insect community, and those are the ones that have been studied and ones people have focused on and appreciate a little bit more than some of the other ones. But something you may not realize with bumblebees, there are captive bumblebee populations that are used in greenhouses. So if you buy greenhouse tomatoes during the winter, most likely those are pollinated by captive bumblebees, because bumblebees are very efficient at pollinating tomato plants with the buzz pollination that is required by them. Again, fragmentation and habitat loss, pesticide use and climate change, all affecting our bumblebee populations. They're a really good pollinator because they will pollinate at lower temperatures and in darker daylight conditions than some of the other pollinators. So they do a little bit more, they stay in a smaller area than bumblebees or than honeybees do. So if they're around your crops, around your fields, then they do a good job. Fireflies, that's the light pollution is part of it. Cleaning up our environment where we're removing some of the dead materials and some of the plants in the weeds and mowing a little bit too much where the habitat for the fireflies is. I asked this question at the first presentation of this, so see if anybody remembers. Who are the second most important pollinator group after bees? We got beetles, what? Somebody got it. Flies. All right, so flies are considered the second most important pollinator group. So how's the fly population in your backyard? So, and that's, again, one of the issues, relatively little research into fly pollination has been conducted. Bees carry greater volumes of pollen, but flies make more visits to flowers. So they're transferring the pollen from flower to flower, getting that genetic material spread around a lot better than the bees are. And something I added that I didn't put in there before is not just the pollinators, but they're also predators. So they're preying on aphids and other things really well and a little bit better than some of the bees and wasps may be doing. So these guys are usually small, think of housefly size, but kind of looking like bees. Some of them are half the size of a housefly. If you start looking for them, you'll find them. There are quite a few species around. Getting them identified down to species is going to be difficult. We don't have that expertise in the general public of trying to identify a lot of these insect species. So these were the statistics I had put up. I didn't find anything new on them, but showing a big decline in not just the number of individuals, but also the number of species. So something that is starting to get a little bit more attention by science and studies. But again, some of these studies, I don't have the dates for these studies. Yeah, so 89 to 2014. So now if you wanted to start that study this year, you're talking going 20, 30 years from now to get a good set of data. So how can we help the insect world thrive and survive? A lot of this is similar to what I put up the last time. And some of these things you're really you know already. So adding flower-rich areas around the margins of agricultural, park, and recreation land. That is something that has been taken off a little bit more. Part of Cuyahoga County Parks and Trails, Emerson Park, that's one of the things they've been doing is twofold. One was because of lack of workers to mow the lawn. So why are we mowing this part that's usually wet anyways, that no one from the public is going to go in? Why are we mowing that piece of land to keep it mowed? Doesn't make sense. So they've been taking some things out of mowing rotations and trying to enhance them with some wildflowers. Something you can do with your own yard, something I've done with my yard since we moved in. One section that I've never mowed since I lived there. Neighbor didn't like it too much, but it's being an advocate, so coming to meetings like this, talking to your friends and neighbors, joining groups that are supporting and promoting the things. Things you can do in your own backyard, enhancing insect habitat throughout the seasons, not just doing it during the summertime, but doing it year round. Native plants, which you guys know a lot about. Limiting use of herbicides and pesticides, leaving the leaves, which in the fall always get some press about leaving the leaves behind, mowing less often. My neighbor used to joke that I would mow my lawn once a month, whether it needed it or not. So he didn't care for, since he actually owns a lawn mowing business, he didn't like it that I was mowing it as much as he thought it should be, but he survived, I survived. Again, removing some of your lawn, providing water or bare ground, depending on what habitats are around you, turning off outside lights, surprising, especially this area I'm sure is a lot worse than my area, but how many lights people leave on. And Christmas time's a little different, but throughout the summer especially, the lights are going to affect the moths and the lightning bugs and other things. So, and then trying to figure out other things to do outside of those normal things that we always associate with trying to improve habitat and wildlife. Voting, and we, especially politically, we've talked a lot about voting the last 5 or 6 years, a bit more than we have in the past. But you shouldn't be just thinking of it as a political thing. It should be something of what is important to you. Why are you voting for somebody and what you can do? And I forgot, there is a bill in the New York State Senate on, I'm trying to remember the name of it. It's basically with the monarch butterfly, with the designation of its migration being endangered earlier this year by the the Union of Concerned International Scientists. I don't know if that's right. I'm trying to think of the acronym. One of our state legislators did introduce a bill for I think it's called the Monarch Protection or Monarch Migration Protection Act or something, that would end up funding habitat protection for monarch butterflies, but that would also protect things for a lot of other uses. So that kind of goes with the political and the choices and your vote. talking to your legislature about that and trying to promote things like that, even with your town or in the county, what they're doing with their park system and how they're coping with some of these things. Educating yourselves, so you're already doing that today by coming to this. Staying informed, being a citizen scientist, and all those other fun things that go with it. So a lot of these things for insects are the same for different types of insects. So if you're a bee, whether you're a bumblebee or a mason bee, so planting flowers for them to forage on, a place for them to nest, and having a pesticide-free environment are kind of help them in lots of different ways. Lightning bugs, turning off your outside lights, leaving logs or leaf litter around, creating water features, avoiding the use of pesticides, use natural fertilizers, don't over mow your lawn. If you've ever mowed your lawn when it's getting dark, you'll see sometimes little streaks of glowing light in your lawn after you go over it with the lawnmower. That's not a good thing for the lightning bugs. And again, going to the native trees and plants, and do not introduce earthworms to your yard. So those are the big things. Pollinators, thing that most everybody knows about planting flowers for them, but you also want stuff throughout the seasons for them, not just the summer flowers. You want early spring, summer, fall, late fall. So different types of flowers, different things blooming different times, trying to protect their habitat in the winter time. So if you are doing like a rotational mowing, maybe not timing it so you're not disrupting the pollinators, whether it's spring, summer, or fall, trying to help them out a little bit each different season. In diversity, the more diverse the habitats and the layers around your landscape, the more diversity you'll have with the wildlife that is using those spaces. So thinking about different things where you can plant, cherry tree or other things, as well as planting some of the flowers underneath it. Now this is for birds, for the diversity of habitats, but that will also transition to the insects, because the birds are there because they're feeding on the insects that are there. So having those different layers is very important, and again, different habitats, more wildlife you have. There are lots of different ways you can be a bee farmer. You can buy and use some artificial nesting cavities or make your own for them, but doing things more passively, again, no insecticides, leaving the leaves, leaving snags, the bare ground, the native flowers, the unmowed lawn. And really a big part is learning more, learning what you can do for different species or different insects. Our rusty patch bumblebee there in the corner is our first bumblebee to be listed as an endangered species. So what can you do if they're in your area? What can you do to help promote them and their life? So this is something from the 70s, which was done more in urban areas, called being a guerrilla gardener was the term that was used at that time. It's done a lot in cities where there are a lot of vacant lots, usually fenced off, so you couldn't get into them. So how would you beautify them? So that was making it what was called a seed bomb. I've changed what I'm doing to be more of a seed bead, so it's not as big softball or baseball size clump. It's a smaller piece of soil, but it's soil and clay mixed together, and then you add the seeds of the wildflowers to it. The idea in the 70s was if you can't get into the vacant lot, you can make this ball and toss it over the fence. The soil will help protect the seeds until the conditions are right for the seed to germinate. It'll give it some soil to start out in. The clay holds it together so that the predators or birds or other things aren't taking it apart, or the seeds aren't just being scattered by the wind. They're sticking there. And then as it gets wet and the seeds grow, the clay and the soil that you mixed in with it break apart and give the seeds a base to use. So I'll be doing this, and I forgot all my handouts. I forgot to bring them. But on December 17th, we'll be talking a little bit about the native plants and what you can do. And then we'll be making some of the seed beads. I have 10 different seeds, from purple coneflower, Joe Pye weed, New York ironweed, milkweed, common milkweed, New England aster, blue aster, sneeze weed, which isn't really a nice name for it, but it's a really, Helen's flower is another name for it. It's a nice yellow flower. And I'm forgetting the last couple, but there's 10 seeds to choose from. So you can make these little beads. You can let them dry and then use them as Christmas presents if you would like, or use them to plant yourself. The Xerces Society has a lot of information on insects because that's what they do. So they're for invertebrates. So insects being invertebrates, one of the bigger groups of invertebrates, they have lots of information on almost any topic related to what we've been talking about. And a lot of good information there. This is roadsides in the Departments of Transportation have been doing a little bit better with some of these things, but they also need to be encouraged to do even more. So leaving some strips wild, or planting wildflowers along the strips of roads, timing their mowing so they're not mowing all the milkweed over when the caterpillars are out there feeding, and things like that. More has been done in recent years than in the past. It's still tough depending on who's in charge of that department to make them see the benefit. Goes back kind of to that institutional learning. If you've learned to do it one way and it's always been done that one way, why should you change to make things different or better or harder on yourself? But it does help with the wildlife. So 3 steps to conserving pollinators in parks and golf courses. We all like to go to parks. Some of us like to go to golf courses. So you can encourage those places that you visit to do these things, to recognize if there are areas of the golf course or the park that could be enhanced for pollinators. Adjusting those mowing periods a week or two could make a big difference for some wildlife, and just kind of educating and encouraging those things. There are a lot of different programs in different parts of the country and of the world that help with some of these things. So Monarchs in the Rough was one that was specifically tailored towards golf courses and monarch butterflies. Some of them, I'm trying to remember which one of these it was. It may have been the patch for the pollinators. It was encouraging people to do just a 3-foot by 3-foot square of pollinator habitat. So even if you're living in a city and have a small yard, you may have that 3-foot by 3-foot patch. Instead of having it lawn, you could add it to make it wildflower. So they're trying to get communities to do that, so that your 3-foot by 3-foot patch is not going to save the world, but if all your neighbors do that, you're making a connection of habitats that will help wildlife, not just the insects, but also some of those birds and other things that rely on it. So doing small things, enough people doing small things will have a big effect. And there's lots of citizen science projects out there. So if you're not doing any of them, you're looking for something to do. There's a ton of them out there. These are just a sampling of them that I have come across. Some of them are simply just reporting what you're seeing. So eBird, you're just reporting the birds that you're seeing, and that information goes into a database that people can use to see how populations are doing. And some of the butterfly ones and the bee ones are similar to that, trying to build that database so that we can, doesn't help us this year, it may help somebody in 20 years to look back and see what was going on. Journey North, you can track monarch butterflies, you can track spring and some plants blooming and things to help with that science. I don't have up here the Monarch Watch, which is tagging monarch butterflies to learn more about them and their populations. The one thing to remember too, the study that started this all was a volunteer group. It wasn't just amateur scientists, some of them were more professional entomologists, but they're all just a volunteer group of people that formed the society years ago and just follow the same protocol year after year, collecting different things. So they're the ones, their data from their studies are the ones that brought this back into the public press and public knowledge. So again, there were lots of headlines 4 or 5 years ago. You're not seeing the insect apocalypse headlines anymore. It was just that year, although everybody was doing stories on them. Now something else is in the headlines, and tomorrow there'll be something new in the headlines. So looking at things and trying to figure out what's going on is still an issue. The problem hasn't changed. It's just we stopped thinking about the problem. You can try not thinking about your gas gauge getting lower, but eventually you're going to run into not having any gas in your car. So we run out of insects. We can't wait until we run out of insects. We have to try to do stuff now to help them and help everything else. I did not update my reference list. That was one of the things I was going to do this morning, and then I got doing other parts of the presentation. So yeah, there's a lot of different things. One of the good things with the pandemic, there are a lot more resources online. There are a lot more presentations that people Zoomed and recorded, and you can go back and watch. So either YouTube or so the one was from Virginia. There's something from the Cincinnati Nature Center that they do that anybody can join throughout the world. So there are some of that little silver lining to the pandemic, that there are things out there that you can pay attention to, you can look back at and read or listen to. Even a couple of NPR stories that I went back to and listened to for this presentation. There are a couple of books out on the issue, so it's how long it's been that people are actually able to write books about it. This was one, Silent Earth by Dave Golson. Some of his information was in the program. I haven't read all of the book. I kind of skipped through a couple different chapters getting ready for it. But he did have chapters on the causes and the importance of insects, the evidence of the decline. He's one that has done a lot of research on it. It's more European based, but he does pull in other things from it. But one of the reasons he wrote the book was he was waiting for somebody to release a study, and nobody was releasing the studies, so he did it himself. He is an entomologist and a scientist, so he did do his due diligence with that. Any questions? I don't know if I went too quickly or gave you too much information or not enough information. Yes.
Because I was reading an article that I saw that has acceptable level of pesticides in there. And so I thought, I don't need it. I started using it until then. But it's because of these pesticides are universal. They are in the wheat grain.
Yeah. Well, that's the new.
Wait, please repeat the question for those of us on Zoom.
Okay. It was more of a comment than a question that she has stopped eating Cheerios because she found out that Cheerios or General Mills now has an acceptable level of pesticides in their products. So she didn't want to be ingesting the pesticides, so she's trying to find other sources. So that's with the neonicotinoids, because what you used to do is you would wash your fruit to get the poison, to get the whatever they treated the crops with. You'd wash it to get everything off of it, and hopefully you wash it good enough. But with the neonicotinoids, you can't wash it off because it's inside the plant. So you are ingesting some of those, and there have been some studies that have looked at what we have in our systems. I didn't put any things like that, and I didn't read. Again, a lot of rabbit holes to go down when I was looking at this presentation, so I tried not to go down too many. But that is an issue, and that's why it's affecting things that aren't eating the crops, but the pollen or the runoff from the fields going into the hedgerows or the neighboring fields, where those pesticides are then being intake by the wild plants. So it's doing your research to find out what you're eating and how healthy it is, and making those choices is important. But there are acceptable levels. There are, and I forgot the acronym, levels that are non-toxic. So some of the studies are, well, this you can go up to this point before it becomes toxic, so you got to stay below this. But those non-toxic levels also cause problems for the insects. It may cause more confusion in their navigation, which was one of the theories with honeybees. They were just getting lost because they were getting confused because of the insecticides were playing with their navigation. So they couldn't find the way back to their colony. So just because it's not killing them doesn't mean it's not harming them. And the same thing with a lot of the water studies that are being done, what levels are not causing harm as opposed to not causing death of the insects are totally different. I recall that in Canada there have been laws preventing people from using a lot of pesticides on their lawns. I don't know how that's carried forward, and whether there are any movements like that in the States, except in commercial things, or at least on the football fields, especially. I know that decrease, but for individual homeowners, again, you can talk whatever you want. Yeah. So the question for the people on Zoom was about using pesticides at home as compared to industrial use of them or farming use of them. That they had heard in Canada that there were regulations for homeowners as well. I haven't heard of any movement in the US for that. it's, like I said earlier, it's kind of the opposite where the farming industry, the commercial use of it is very restricted, but the private use isn't. I mean, you can go to any garden store you want and find a lot of these insecticides and use them. You're supposed to follow the directions and follow the label. But how many people actually read the directions and the label before they go out and spray things? So you could have greater concentrations in somebody's yard than you do in the neighboring farm field. Part of the regulation is the farm field is much bigger and a much bigger impact than the individual homeowner. And individuals don't like being told not to do something. So, but that would be something to talk to legislators about and try to get something going to limit that. And they have taken off some herbicides mainly because of health problems with people, but not necessarily with wildlife. So question being, using neonics to treat ash trees for the emerald ash borer. There's conflicting information. It depends on what state you're in. There are other insecticides that aren't neonics that are being used to treat ash trees for the emerald ash borer. The neonics were the ones that were used at first because of their systemic properties, so that all you would have to do is wet the soil around the tree would intake the pesticides and protect the tree. I think they're trying to get away from that in some states and some areas, but I'm not sure if federally or nationally, if there's anything with that. And I haven't, the last I looked into it, it was treating them with neonics was what was recommended. And a lot of that's going to be because you're hiring somebody to do it. So the person you're hiring has to go by the label of the product they're using. So they're not supposed to use something that's not specifically listed for that use. So if neonics are the only thing that's listed, then they're the only thing that's the option at that point. But I know there is another insecticide that is being used in some areas. I forgot the name of it. It may be I think the scary part may have been that it's a new class of insecticide. So long-term effects, again, we don't know on that.
Yeah, let's bird and sprinkle with sea salt. And I just hadn't heard that before. Sea salt.
Provide bare ground and shallow bird bath filled with soil, sprinkle sea salt and keep moist to create a source of water and minerals for pollinators. So what you're doing, in that case, it's not putting it in the bird bath, but it's putting it on the damp soil. So that's what you're doing. Butterflies and other insects, they need the minerals in order to reproduce. So putting the salt, you're dissolving the salt into the soil. So it's called puddling for butterflies. That they'll go to usually it's like after a thunderstorm or mud puddle that's evaporating, they'll go to the mud where the minerals have been concentrated by the evaporation of the water. So they're intaking those minerals as part of their diet. Table salt. Right. Yeah. Yeah. So so the salt that I don't like using in cooking is kosher salt, because kosher salt has all those minerals taken out of them. It's as close to the pure salt as it can be. So sea salt, maybe the Himalayan salt, I don't know, some of those others might have more of the minerals and the trace minerals that aren't found in other things. So you're looking for that. I mean, the other thing is just to keep wetting the soil with rainwater or well water or something that is just evaporating and leaving the trace minerals behind. Correct. So that's, yeah, instead of using the bird bath, you can do it in like I said, you just do it in a mud puddle, you can do it in a flower pot, anything, just something to confine so that the water is evaporating from there and leaving the minerals behind. You're welcome.
Jim, there are a bunch of questions in the chat. Would you like me to read you them?
Sure.
First one is, aren't beetles the most abundant insects? If they are declining, won't that have a broad impact?
So yes. So the question was, are beetles the most numerous insect? And the answer is yes. If they're declining, again, any insect, any animal that's declining, you're taking away those resources, especially things that eat them. You're taking away the resources from further up the food chain. So anything declining is not good for the whole ecosystem. Beetles especially are very numerous and very diverse.
Okay, this one's a three-part one about the interactions between insects and fish. Do you know of good studies from the Finger Lakes on the importance of insects to fish populations?
So insects and fish in Finger Lakes studies, I do not know of any studies in the Finger Lakes that have been looking at insect populations. That would be a good study for somebody to do, and it would have commercial fishing implications as well as sports fishing implications. So as well as the health of the Finger Lakes. So that's an interesting thought, and that would be, like I said, a good study for somebody to run with.
And perhaps the other two with that was, what is happening with fish populations in terms of their numbers? And is there a documented link in aquatic and terrestrial insect decline with fish decline?
So declines with fish and insects, and I have not come across any of those studies. There may be some. I didn't look into the fish. Again, that's kind of my bias. But yeah, that would be something that should be looked into. And that's one of the difficulties with science is in some of these studies is it's a lot harder to study the number of fish than it is the number of birds. So you can see the birds traveling through your yard, but you don't see the fish that are off your dock or swimming by your dock or through the lake. So those type of things are harder to study, so they're studied less, and that gets into some of the bias with the research. But another study that probably should be done, especially with the increase of at least being able to detect what pesticides and what chemicals are in the water. We're able to do that a lot easier and down to a lot smaller amounts of a given pesticide or chemical in the water. So it's probably something somebody should be doing, but whether somebody will is always a problem.
Okay, and the last question in the chat was asking, what is the minimum size that you need to have an effective patch for insects?
So the minimum size for an effective patch for insects.
So minimum size for a meadow.
Yeah, I would say whatever, as big as you can make it, it would be my answer. So if you only have a 3 foot by 3 foot or a 2 foot spot, or even if you only have a window box, putting native plants and flowers and things in those would help increase food resources and resources for the pollinators. So I don't, there probably is for an ecologically significant size. But depending on your landscape and what you can do, anything, any little thing you can do would hopefully have an impact. And again, if enough people do little things, they hopefully will add up into bigger results than just the individual.
Okay, that was, there
Yeah,
were
well-
comments in the chat as well. I don't know if you want me to go through those.
I don't know.
Well, we're about wrapping up here.
Yeah,
Yeah.
I think we have to get out of the room.
Yeah, I don't see if I can see them.
If
They're-
we
they're
can
in the
see them, I might be able to look and reply. If anybody on Zoom wants to email me at the Sterling Nature Center with questions or comments, they can do that as well. snc@cuyacounty.us is my email address, or finding us on Facebook. You can contact me there too.